So today, the agenda is I would like to discuss this Arduino Uno board again, and that from that MCU perspective, that ATmega328. So this is basically in continuation of my earlier blog related to this Arduino engineering approach. I've given the link here. So please go through that to understand the background that why I am discussing this here. So we will validate that ATmega 328 concepts with practical approach. We'll go through this, actual original documents and then analyze with our board, whatever the tiny board we have, and that you will realize by the end, we reach in this document. So here is the block diagram, basically full block diagram. So the idea about this Arduino discussion is based on that I would like to use this platform and further, you know, uh, in comparison with other platforms, other devices, other vendors. Otherwise, lot of stuff is already available on the website. But what I have done this particular task, making the notes here so that I can utilize this reference for future. So that you will realize. For example, here when we call it full device or SoC, system on chip, or platform. So it comes with different building blocks and along with a core. So similarly, if you will see the device ARM related, so that will have ARM core, other building blocks. If you will go for some, let's say, power PC based networking devices, that will have power PC core, other building block. There may be something related to Ethernet, fast Ethernet, gigabit Ethernet. So it depends upon what kind of application, what kind of area you are looking for. And it can be a single core, dual core, multi core, that there is no limit on that. So this building block looks pretty complex, although it is a very small microcontroller. You can say different blocks are available, IO ports available. We can see a timer available. We can see A to D ADC converter is available, and this USART is available for serial communication, and even different power saving modes are available. And one thing for this particular microcontroller is that this was one of the microcontroller which was designed with inbuilt flash. So earlier, basically, there were devices which were using EEPROM, OTP, one-time programmable devices. Once you program once and then it will be useless for you. So that is basically for factory-based kind of, and electrically erasable EEPROM, or maybe some EEPROM which we use UV ROM to ultraviolet rays to erase those. So this was the one. So look complex in terms of a small device. So too much to discuss here. So for hobbies especially, this is complex. But let's divide this task, this particular job into many tasks. So let's start from this core itself. Why core itself? Because our discussion is right now from the point of view of software development or application development, which we can design on top of available platform. So our software will run on this particular core. So let's discuss that. So this core is the AVR microprocessor. It's basically, the name is based on the developers Elf and Vigard RISC processor, and two developers, and it is 8-bit Little Indian RISC processor from Atmel, now acquired by Microchip. So the program is going to execute on this Harvard architecture RISC core, and program counter is 14-bit. So thus addressing will be 16K program memory locations. So this, you can see, different registers here, some special registers for indirect addressing, 16-bit registers, and these are chip specific logics. And in the Harvard architecture, we can see separate mechanism for program and separate for data bus, and this is the arithmetic logic unit, and we will see that there is a internal stack pointer taking care of stack. There will be status register to provide different flags generated by different mathematical or logical operations inside this. And this is the instruction decoder, so it is fetching the instruction from this flash memory and then sending to instruction decoding, then sending to to this particular block. So this way it basically works. And for any standard other CPU, it will have the program counter also. It will have different kind of registers. So device memory map. First of all, we will look into program memory. So many people can question, why should I learn this device program memory map? I have standard memory is there, but why should? Because since the device has very limited program memory, it is important to understand where this is being used and how can we optimize that for real field application. So as of now, it comes with default bootloader, and because of that bootloader, we can communicate with the board without any external debugger or anything like that. But if you are planning for a field-based product and you are sort of this program memory, so you can get rid of that bootloader also. Only in that case you will have to use external programmer or some mechanism to program your devices. That is one thing. So and other way, maybe you can port that bootloader, you can optimize the bootloader code according to your requirement. So it is important that. So how to find out that what that program memory we discussed in the last block, that divided between this bootloader and application. But how this bootloader size is defined, by the way. So bootloader size is defined in such a way that there are 2 bits. This boot size 1, size 0, and that these are called these are in few setting bytes. So these few setting bytes, by the way, these are reset configuration word. So this provides some sort of mechanism. So all devices, all microcontroller, those comes with such mechanism that so that one can have option to change the factory default settings. For example, you have different kind of clock source, or you want to you want to increase that frequency whatever your device provides, and you want to utilize different multiplexing options of that device. So you have to have certain settings. So I am not discussing all settings right now. I'm setting only these 2 settings. So based on these 2 settings, you can say one is 256 watts. So and this is the 3FF00, 3FF. This is the bootloader flash section. And please note that this is word. Okay, 16-bit here. So how to verify or backup existing flash program? So let's see what is inside our existing board. So reading flash is not like straightforward. You cannot simply provide that address and read from that. And also, why we should do, we have already some, somebody developed this AVR utility, and that we can utilize here. And if you install this in AVR, then you can utilize this. Okay. And that is that benefit of the community these days. But once you get this utility, so avoid write or program feature. This is because if you don't know much about the bootloader, you may corrupt it. So later you have to use some external means to reprogram it, some external debugger or something. So this is how I use this particular command, and this particular command based on that that particular site, and this gives like what is that your device and what connection type you are using. We are using just Arduino connection, and also which port you are using. We are not using any external debugger here, and for what purpose flash and read. So to this particular file, then okay, character wise, so this will read, and you will have this default.hex file. So I got that file. After that, I had to verify that particular file, because as per our information from the top chart, 0 to this address should be application. After that, this should be the, so we can anyway verify our application first at 0 location. So what I did in the last block, I discussed how to get the build information of particular application. So whatever application I was doing, I took that build and I renamed this file here as this Arduino, no, whatever that just to be read here, hex file default.hex. I renamed this, and in the hex editor, and the right side is that my disassembler file from the build, and I can see that it is pretty much matching with that. So at 0, application code is confirmed. Now how can I verify that bootloader code? Okay, so bootloader code, again we have OptiBoot in this. So OptiBoot is the folder is there, and this also we have seen last time, the list file, there is a list file is there, and that list file, and we can, if I compare the data, so I find this 7E000 address. Okay, so is it correct? And what the fuse bit basically tell us? So using the Avrdude, we can try all this configuration, we can read this configuration, and fuse bits, all fuse bits are 000, and it is very difficult to understand that all configuration 0 not possible. So something wrong with this particular utility in terms of this feature, because our anyway reading that program worked fine. So let's go further, and after searching a bit, so first of all I tried to understand what is this fuse byte and where those bits are. So 2 bits were there, and according to me, I at least some of these, I was expecting, at least even if it is 0, all 0, so other fuse bits should not be non-zero. So based on that, I tried to find out in the library. So there is a function called this particular function. So I used a simple application code, and that I will discuss in our next post. So this was the output. Okay, so this is as fuse is D. So I basically in the setup itself, I use that function and display all data, and based on that, this is coming to, if you see this DE, so means 1 1 1, all 3, so this is coming 1 1. It means that our data should be this range 256 words from this to this, but what we observed, that was 7e. Okay, so then what is the problem? How 7e? So there are 2 points here. Number one, as per the build configuration also we verified that 7e00, that is matching, also working. Okay, so as I mentioned earlier, the flashbang size is given in words 16 bits. So anyway, this is going to be double. So this will be same thing. So we have to shift it left side. And further, if you read that particular section addressing the flash during the cell programming in the data sheet, and all the data sheet link, everything I have given below, so you will see that it has shifted left. Okay, so all the references are here, whatever I have taken. So there are a lot of documents at that website, but still, you can refer to this. This is the link for actually all the documents. If you go to this particular link and if you click on go further documentation, so a lot of stuff is already available. But my focus was on some particular stuff, so I have selected few things from this, and as well as some of other from that web. I put it here. Okay, so hope this you understood that the discussion of this program memory, and next time we will discuss that other data memory, IO memory and all that. And thanks for your time. Okay, please subscribe that YouTube channel.